Assalamu alaikum. Today I am here with another regression assumption, that is autocorrelation. It is also a violation to regression assumption, and it is very important to analyze the autocorrelation issue in our model. Autocorrelation is basically the correlation among your errors. Errors are basically your the rest of the part of your model which are not being explained by your independent variable. Here I will show you how you can detect the autocorrelation in your model. Firstly, we need a data set. I am using a exemplary data set of SP500. For this, the command is sysuse SP500. It is a example data set, and I have described the data. It provides the date, open, high, low, close, volume, and change for your SP500 data. You need to generate a time variable in order to analyze the autocorrelation issue in your data set, and then you need to tset the time, TSET time variable, and the time variable have been now set in this data file. Then you need to process the regression command, regression model. In my case, I have used close as a dependent variable and volume as an independent variable. You can use more variable as well, and you can use variables according to your model. Here you can see the regression results can be seen. Now, how can we detect the autocorrelation in a regression model? Firstly, we need to predict the errors for the model. You can see that only 9% of the model is being explained by this independent variable. Rest of the 90% of the model is not being explained. Therefore, those 90% of unexplained part is the error part in our data. For this, I am predicting the error of our model. The command is predict. You can use whatever name you want to give it, comma R. You can use R, or you can use resid, RESID, whatever you want, but both of them provides the same result. Here you can see the residuals have been generated for this model. Now I will show you the autocorrelation from a line chart. This is a time series data, therefore the line chart can only be produced for a time series data, not for the panel data. However, the rest of the commands are same for panel data as well, but this line chart is for the time series. Here you can see the ups and downs in the data of time against the residuals. But how can you analyze this data without any information? For this, the next command will provide you difference in this graph we are going to generate and in the previous graph. For this, the command is test line u hat if e sample is 1, y line, right? I will explain this command with the graph. We are generating the graph for our errors right now, because autocorrelation is the correlation among your error terms. And now you can see a line have been generated which provides a view that this much data is in the positive part and this much data is in the negative part. To analyze the time series ups and downs in the returns value, it is easy to analyze the time series data. However, how can we detect the autocorrelation? Before proceeding to detect how we can detect autocorrelation, it is very important to check the error term firstly. For this, I am using the regression for error terms only. Here you can see I have used both time u hat, but in the next variable I have used L dot. L dot is the lagged value of our error term. Lagged value means the value from before or for previous day. U hat is providing the error term for the present time, L you had is providing the error term for the previous day, right? Lagged means the previous one, and you need to enter this, and you can see that R squared is completely changed, and rest of the results have also been completely changed. This provides you with the analysis how you can use the predicted values or error values for your model. Now let's move on how we can detect the autocorrelation. For this you need to again use the regression model, the original regression model, and then you need to add the Durbin-Watson test. Durbin-Watson test, for this the command is estat d Watson. Durbin-Watson test interpretation is if this value is equal to 2, then there is no autocorrelation. However, if it is less than 2 and greater than 2, then that means there exists an autocorrelation. It can either be negative or it can either be positive. But however, if it is closer to 2, then there is no autocorrelation. But in our case, there exists autocorrelation because the value is far from 2. That means there exists an autocorrelation in our data set. Let's move on to another method, which is the Bush-Godfrey test. For this, again, you need to process your regression model, and then you need to process the command to analyze the Bush-Godfrey test. For this, the command is estat b Godfrey, lag. You can either check it for lag 1 and you can either check it for lag 2. It is upon your choice, but I am using it for lag 1. Lag 1 is for simply the previous day's autocorrelation test, and you can see that it is showing the significance. That means there exists serial correlation, which is the autocorrelation in our data. The interpretation for this is if the value p-value is less than 5%, that means there exists serial correlation. However, if the value is greater than 5%, that means there is no autocorrelation violation in our data. However, I will show you how you can check for lag 2 as well, and again you can see that there exists autocorrelation. And if you do not want to check for the lag 1, you can simply put 0 over here, and it provides you with the invalid elements, because you cannot check the autocorrelation for the present time, right? Because autocorrelation definition is basically you can check the correlation of your errors for the present value with the previous value, right? Autocorrelation provides the relationship and correlation among the errors of present time and with the lagged errors, that is the previous day errors. So you cannot check the Bush-Godfrey test for your present time. You can check either for the lag 1, lag 2, or more of the lags you want to check, right? Here you can see I have shown you with 2 lags. That means both of the lags showing there exist autocorrelation, which is the serial correlation in our data set. Let's move on to test 3. For this you need to again process your original regression, and you need to process this command. The command is wn test q time lags 1, right? This is basically the Portman-Newton's test for white noise, and it is also providing you with the significance. That means there exists autocorrelation in our data. It is also called as Q test as well. After processing this command, you need to process the acid test time as well. For this, firstly you need to install the AC test command. I have already installed it, so it will appear that this is already installed in my database. Whenever you are installing a command, it is very important that your computer is connected with an internet connection so that it can install the command, right? And you can see that it is showing that it is already already exist in my directory, so I don't need to install it again. But if you haven't, then you can use this command. And then the command to check for Q test and autocorrelation is AC test time comma lags, and I am checking it for lag 1 BP small, and it will provide you the autocorrelation test with the hypothesis, and provides you with the chi-square value and with the p-value. You can see that this lag is providing the autocorrelation results for present at rate specified, and this results provide you the results for present at lag specified. That means this result is showing for the lagged one, this one is for the present one, and you can see that both of are significant. That means we cannot use the we can see that there exists autocorrelation in the data. However, you can also check for more lags. I can show you, like I am using it for lag 2 or lag 3 or lag 4. It is upon your choice, and I am showing you with lag 2, and in lag 2 there is still showing significance. That means there exists autocorrelation. You can check it for lag 4, let's say, and for all 4 lags it is still showing the significance. That means autocorrelation is seriously impacting your model, because it is correlated till the lag 4 as well. That means it is seriously affecting your model. These were some of the methods how you can analyze the autocorrelation issue in your data, in your model. In the next video, I will show you how you can fix the autocorrelation issue. Till then, thank you and Allah Hafiz.